So the next question is, what is naive in naive-Bayes algorithm? So in simple terms, a naive-Bayes classifier assumes that the presence of a particular feature of a class is unrelated to the presence of any other feature given the class variable. Okay, so what is this naive Bayes? So naive Bayes makes the assumption that features of a measurement are independent of each other. This is naive because it is never true or almost never true. So naive Bayes is a very intuitive classification algorithm. It asks the question, given these features, does this measurement belong to class A or class B? And answers it by taking the proportion of all previous measurements with the same features belonging to class A multiplied by the proportion of all measurements in class A. If this number is bigger than the corresponding calculation for class B, then we say the measurement belongs in class A. So that's why it is known as naivebase. So naivebase classifiers are a family of simple probabilistic classifiers based on applying Bayes' theorem with strong independence assumptions between the features. They are among the simplest Bayesian network models, but coupled with kernel density estimation, they can achieve higher accuracy levels. So when we are working on a classification problem and have generated the set of hypotheses, created features, and discussed the importance of variables, within an hour, stakeholders want to see the first cut of the model. So in this case, we have hundreds of thousands of data points and quite a few variables in your training data set. In such a situation, we can use the naivebase, which can be extremely fast relative to other classification algorithms. It works on Bayes' theorem of probability to predict the class of unknown datasets. So naive-Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm, but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. To start with, consider a fictional dataset that describes the weather conditions for playing a game of golf. Given the weather conditions, each tuple classifies the conditions as fit, that is yes, or unfit, that is no, for playing golf. The dataset is divided into feature matrix and response vector. The fundamental naive-Bayes assumption is that each feature makes an independent, equal contribution to the outcome. With relation to our dataset, this concept can be understood as that we assume that no pair of features are dependent. For example, the temperature being hot has nothing to do with the humidity, or the outlook being rainy has no effect on the winds. Hence, the features are assumed to be independent. Secondly, each feature is given the same weight. For example, knowing only temperature and humidity alone cannot predict the outcome accurately. None of the attributes is irrelevant and assumed to be contributing equally to the outcome. Okay, so this is the naivebase algorithm. Then the next question, what is linear regression? So linear regression is a very simple and easy algorithm in machine learning. So it's a kind of supervised learning. So let's see what is linear regression. So linear regression makes predictions for continuous or numeric variables such as sales, salary, age, product, price, etc. It shows a linear relationship between a input and the output variables. Hence, it's called as linear regression. Since linear regression shows the linear relationship, which means it finds how the value of the dependent variable is changing according to the value of the independent variable. So in this regression, x is the independent variable and y is the dependent variable. We have simple linear regression where there is one input and one output. So if a single independent variable is used to predict the value of a numerical dependent, then such a linear regression is called simple linear regression. And we have multiple linear regression where more than one independent variable is used to predict the value of a numerical dependent variable. In simple linear regression, we have positive linear relationship and negative linear relationship. When x increases, if y also increases, then that is known as positive relationship. And when x increases, y decreases, or vice versa, then it is called as negative linear relationship. So for model performance, we use R-square method that determines the goodness of fit. It measures the strength of the relationship between the dependent and the independent variable on a scale of 0 to 100%. The high value of R square determines the less difference between the actual output and the predicted output, and hence it's a good model. It's also called coefficient of determination for multiple regression. So this is about linear regression. The next question, difference between expected value and the mean value. So what is the expected value and the mean value? So expectation is the average value or mean of a random variable, not a probability distribution. The sample mean is defined as the expectation of the data with respect to the empirical distribution of the observed data. This makes it simply the arithmetic average of the data. So this is the difference between expected value and the mean value. Then what is ensemble learning? So it's a very, very important concept in machine learning or in data science. So ensemble learning is used widely. So let's understand what is ensemble learning. So ensemble models in machine learning operate on a similar idea. They combine the decisions from multiple models to improve the overall performance. This can be achieved in various ways, which we will discover. Ensemble modeling is a powerful way to improve the performance of your model. It usually pays off to apply ensemble learning over and above various models you might be building. Time and again, people have used ensemble models in competitions like Kaggle and benefited from it. Ensemble learning is a broad topic and is only confined by your own imagination. So let's see now what is bagging and boosting. So bagging and boosting are very important terms that are circulated nowadays. So bagging is a method of merging the same type of predictions. Boosting is a method of merging different types of predictions. Bagging decreases variance, not bias, and solves overfitting issues in a model, whereas boosting decreases bias, not variance. In bagging, each model receives an equal weight. In boosting, models are weighed based on their performance. Models are built independently in bagging. New models are affected by a previously built model's performance in boosting. In bagging, training data subsets are drawn randomly with a replacement for the training dataset. In boosting, every new subset comprises the elements that were misclassified by previous models. Bagging is usually applied where the classifier is unstable and has high variance. Boosting is usually applied where the classifier is stable and simple and has high bias. So ensemble is a method used in the machine learning algorithm. It's a method where multiple models or weak learners are trained to rectify the same problem and integrated to gain desired results. Weak models combined rightly give accurate models. First, the base models are needed to set up an ensemble learning method that will be clustered afterwards. In the bagging and boosting algorithms, a single base learning algorithm is used. The reason behind this is that we will have homogeneous weak learners at hand, which will be trained in different ways. So bagging is a homogeneous weak learners model that learns from each other independently in parallel and combines them for determining the model average. Boosting is also a homogeneous weak learners model but works differently from bagging. In this model, learners learn sequentially and adaptively to improve model predictions of a learning algorithm. Bagging is an acronym for bootstrap aggregation and is used to decrease the variance in the prediction model. Bagging is a parallel method that fits different considered learners independently from each other, making it possible to train them simultaneously. The random forest uses bagging, where decision tree models use with higher variance are present. It makes random feature selection to grow trees. Several random trees make a random forest. The AdaBoost uses boosting techniques where a 50% less error is required to maintain the model. Here, boosting can keep or discard a single learner. Otherwise, the iteration is repeated until achieving a better learner. So, this is about ensemble learning. The next value is explain eigenvalue and eigenvector. So, a simple example is that an eigenvector does not change direction in a transformation. For a square matrix A, an eigenvector and eigenvalue make the equation. So A multiplied by V equals lambda multiplied by V, where A is the matrix, V is the eigenvector, lambda is the eigenvalue. So one of the cool things is we can use matrix to do transformations in space, which is used a lot in computer graphics. In that case, the eigenvector is the direction that does not change, and the eigenvalue is the scale of stretch. The next question, define cross validation. So cross validation is again a very important term in machine learning. Okay, so cross validation is a technique for validating the model efficiency by training it on the subset of input data and testing on previously unseen subset of the input data. We can also say that it's a technique to check how a statistical model generalizes to an independent dataset. In machine learning, there is always the need to test the stability of the model. It means based only on the training dataset, we cannot fit our model on the training dataset. For this purpose, we reserve a particular sample of the dataset which was not part of the training dataset. After that, we test our model on that sample before deployment. And this complete process comes under cross-validation. This is something different from the general train test split. So the basic steps for cross-validation are: reserve a subset of dataset as a validation set. Provide the training to the model using the training dataset. Evaluate the model performance using the validation set. If the model performs well with the validation set, perform the further step. Else, check for the issues. So what are the methods used for cross-validation? So there are some common methods that are used for cross-validation, like validation set approach, leave P out cross-validation, leave 1 out cross-validation, k-fold cross-validation, stratified k-fold cross-validation. Okay, so these are the different types of cross-validations happening in machine learning. So what are the steps for the data analytics project? So you can see the steps there. So there are certain steps for data analytics project. So the data analytics life cycle describes the process of conducting a data analytics project, which consists of 6 key steps based on the CRISP-DM methodology. According to Paula Munoz, these steps include understanding the business issue, understanding the dataset, preparing the data, exploratory analysis, validation, and visualization and presentation. So the steps in data analysis process are: understand the business problem. When presented with the data project, you will be given a brief outline of the expectations. From that outline, you should identify the key objectives that the business is trying to uncover. You should examine the overall scope of the work, business objectives, information the stakeholders are seeking, the type of analysis they want to use, and the deliverables. The second step is understanding your data set. There are a variety of tools you can use to organize your data. When presented with a small data set, you can use Excel, but for large data sets, you will likely want to use more rigid tools to explore and prepare your data. Then prepare the data. Once you have organized and identified all the variables in your data set, you can begin cleaning. In this step, you will input missing variables, create new broad categories to help categorize data that does not have a proper place, and remove any duplicates in your data. In imputing average data scores for categories where there are missing values will help the data be processed more efficiently without skewing it. Then we can perform exploratory analysis and modeling. Then we can validate the data. We can visualize and present the findings, right? So these are roughly the steps. So in the last step, that is visualizing, you can begin your data visualization, which is crucial in communicating your findings to the client. Not all clients are data savvy, and interactive visualization tools like Tableau are tremendously useful in illustrating your conclusions to clients. Being able to tell a story with your data is essential. So, telling a story will help explain to the client the value of your findings. So, these are the steps. Okay. The next step is back propagation. What is back propagation? So, back propagation is the essence of neural network training. It is a method of fine tuning the weights of a neural net based on the error rate obtained in the previous epoch. Epoch basically means iteration. Proper tuning of the weights allow you to reduce error rates and to make the model reliable by increasing its generalization. Backpropagation is a short form for backward propagation of errors. It is a standard method for training artificial neural networks. This method helps to calculate the gradient of a loss function with respect to all the weights in the network. So the advantages of backpropagation are it is fast, simple, and easy to program. It has no parameters to tune apart from the numbers of inputs. It is flexible method as it does not require prior knowledge about the network. It is a standard method that generally works well. It does not need any special mention of the features of the function to be learned. We have different types of backpropagation. One is static backpropagation, and the other one is recurrent backpropagation. So this is about backpropagation. Then the next question is what is k-means clustering? So as the name suggests, k-means clustering is a type of clustering algorithm, and clustering is a unsupervised learning type. So k-means clustering is an unsupervised learning algorithm that is used to solve the clustering problems in machine learning or data science. So it groups the unlabeled dataset into different clusters. Here, K defines the number of predefined clusters. So it groups the unlabeled dataset into different clusters. Here, K defines the number of predefined clusters that need to be created in the process. So if K equals 2, there will be 2 clusters. And if K equals 3, there will be 3 clusters and so on. It is an iterative algorithm that divides the unlabeled dataset into K different clusters in such a way that each dataset belongs only one group that has similar properties. It allows us to cluster the data into different groups, and a convenient way to discover the categories of groups in the unlabeled data set on its own without the need for any training. It is a centroid based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of distances between the data points and their corresponding clusters. The algorithm takes the unlabeled dataset as input, divides the dataset into k number of clusters, and repeats the process until it does not find the best clusters. The value of k should be predetermined in this algorithm. So the k-means clustering determines the best value for the k center points or centroids by an iterative process. It assigns each data point to its closest k center. Those data points which are near to the particular k center create a cluster. Hence, each cluster has data points with some commonalities, and it is away from other clusters. So to know more about k-means cluster, we have discussed it in detail in our course. So you can go through the information that we have discussed it. So these are the few questions in this session. We will continue with few more questions in the next session. All right. So any queries you have, you can mail us. Thank you.